Hello everyone. It is a great honor to present our CVPR 2026 paper, FastRef, Fast Prototype Refinement for Few-Shot Industrial Anomaly Detection. This work was completed by PhD students from the School of Computer Science and Technology at Zhejiang University, under the guidance of Associate Professor Long Tian, who has extensive research experience in anomaly detection, together with the collaborative efforts and support from our research team and faculty members. This slide introduces the overall task setting of few-shot industrial anomaly detection, or FSIAD. The objective of FSIAD is to detect and localize anomalies using only a few normal support samples. During inference, both the support images and the query image are first passed through the same feature extractor to obtain their corresponding feature representations. The support features are used to construct normal prototypes, while the query features are matched against these support features to measure feature similarity. Based on the matching results, the model finally predicts the anomaly score map or anomaly mask for defect localization. The key challenge of this task is that only a very limited number of normal support samples are available, making it difficult to construct representative and robust prototypes for accurate anomaly detection. This slide illustrates the motivation behind FastRef. Existing prototype-based FSIAD methods usually treat all query features equally during matching and refinement. However, as shown on the left, query images actually contain both useful normal characteristics and harmful anomalous characteristics. The normal regions provide valuable structural and texture information that can help refine support prototypes and make them more representative for the current query sample. At the same time, anomalous regions may also be transferred during refinement, which can corrupt the prototype representation and negatively affect anomaly localization. To address this issue, FastRef aims to selectively transfer reliable characteristics from the query features while suppressing the influence of anomalous regions. As illustrated on the right, normal characteristics are encouraged to participate in prototype refinement, while the transfer from anomalous regions should be suppressed. Therefore, the enhanced prototypes in FastRef are designed to be both query-aware and anomaly robust through characteristic transfer and anomaly suppression. This slide presents the overall FastRef framework. Our goal is to jointly achieve characteristic transfer and anomaly suppression for robust prototype refinement. To this end, we formulate FastRef as a nested optimization problem, where the optimization simultaneously considers prototype enhancement and anomaly-aware transport regularization. The first component is characteristic transfer, implemented through the transform matrix W as shown in the lower left part. Query features are transferred to the prototype space to obtain enhanced prototypes. This process enriches the prototype representation with query-aware characteristics. However, since the transfer process itself cannot distinguish normal and anomalous regions, anomalous characteristics may also be transferred together. To address this issue, we further introduce anomaly suppression using entropy-regularized optimal transport. As illustrated in the lower right part, the transport matrix T suppresses unreliable and anomaly-sensitive correspondences between enhanced prototypes and original prototypes, reducing the influence of anomalous regions during refinement. Therefore, by jointly optimizing W and T, FastRef achieves query-aware prototype refinement while maintaining robustness against anomaly contamination. This slide presents the iterative optimization process of FastRef. FastRef alternates between characteristic transfer and anomaly suppression to progressively refine the prototypes during inference. The optimization starts by initializing the transform matrix W, which transfers query characteristics into the prototype space. Then, the transport matrix T is updated, using the Sinkhorn algorithm to suppress anomaly-sensitive transport correspondences. After that, W is updated again based on the refined transport information, and the process iterates until convergence or the maximum number of iterations is reached. The lower part of the slide further visualizes how the refinement process works. Without suppression, the transferred characteristics may activate anomaly-related regions and lead to inaccurate anomaly responses. After introducing T-guided suppression, the anomalous transport is effectively reduced, while the valid characteristic transfer delta W still preserves useful normal information. As a result, FastRef produces cleaner and more discriminative anomaly localization maps. This slide presents the experimental results of FastRef from three perspectives: performance improvement, inference efficiency, and ablation analysis. First, FastRef consistently improves the performance of different baseline methods across multiple datasets. As shown in the upper part, integrating FastRef brings stable gains in both image level and pixel level OROC for patch core, win clip, and anomalidino. This demonstrates that the proposed prototype refinement strategy is general and effective across different FSID frameworks. Second, the middle part shows the inference overhead introduced by FastRef. Although FastRef performs iterative refinement during inference, the additional computational cost is very small, with only slight increases in average inference time. Therefore, FastRef still satisfies real-time industrial requirements while achieving better detection performance. Finally, the lower part presents the ablation analysis. The visualization results show that both characteristic transfer through W and anomaly suppression through T contribute to the final performance. Removing either component leads to less accurate anomaly localization. In addition, the balance coefficient lambda is also important for maintaining an appropriate trade-off between transfer and suppression.